All right. So I think you guys can see my screen. So just go ahead and start. So today we have our third consultation session. We're here in recess week. And today we said on the agenda on Slack. So if you go to the projects page, we said today we're going to be looking at our first development sprint. So previously we had a general meeting in one just to set the stage. And then the second consultation, we had our ideation sprint. So at this point, you should have some idea of what you're doing. Now we are going to go through our first development sprint for most of you. However, of course, we have one group that's finishing very soon. For most of their project work, they're pretty much done with all of their lecturing duties. So we're going to hear first from the Diversifying dialogue generation with non-conversational text group. And then for the following timing, after that, we'll have two breakout rooms. I think we will have two teams in the first room. That's the causal estimation group in group 5. I think Evan told us that he's not able to attend this session. So I will follow up with him separately. And then in the second breakout room, we have our other 3 groups, group 10, which is mostly the undergraduate group, along with Wendy Ren, the counterfactual RS and search system group, which is Taka and Adit's group, and then group 7, which is our other largely undergraduate and graduate student and guest students. Okay, so with that, we'll hand it over to Xichun, Yuxi, Xie, and Tian for their sharing.
Okay, can you see my screen? Hello?
Yeah, we can hear you and we can see you. So
okay.
Slides, yeah.
Okay. So basically our work is adapted from this paper to diversify the dialogue generation with non-conversational text. So basically we want to use some text that is from the non-conversational corpus to diversify the form or the vocabulary of the response of dialogue boats. Yeah, so in this original paper, they applied their method on the Chinese corpus. So in our work, our goal is to implement this work in the English dataset. And also we want to, like what the authors say in the future prospect section, we want to classify the datasets according to their topics, like the topics the topics here, the politics and the attitude and emotion and the health, and to see how the non-conversational dataset with different topic can improve the model performance in the dialogue system. Okay, so for our code base, you can click this link and to see our code on the GitHub. And basically, there are 2 parts of our model. The first one is the main model, and it's a sequence to sequence. So given the context, and the model needs to predict the utterance of the response. Yeah. So this is a sequence to sequence model. And then because we want to classify the data sets according to the topic, so we also develop a BERT-based topic model. Okay, so and then it's the data set we use because we want to apply this method in English data sets. So we use the conversational data like daily dialogue and empathetic dialogue because the time is limited. So by now we only use our model on the daily dialogue. And for the non-conversational data, we have collected Twitter and ELI5 and WikiHow to develop our non-conversational data sets. And then we will do evaluation on our method to see whether it works in the English corpus. So for the automatic evaluation metrics, we will use BLUE and the diversity. And for the human evaluation, we will sample some samples from the test data and to let human to evaluate the quality of the generated responses. Okay, so now it's our progress report. So then I think Qixun will share us with the progress by now. So
yeah.
Yeah.
Okay, thanks, Yuxi. So yeah, so just to start to pick things up, right? Like maybe cause maybe previously not all of you were familiar with our project. Only probably Prof Bean has some background with regards to what we were previously doing. So just to catch things up for yeah, just to give a brief summary. So we have various steps. So the first steps of like the steps that we need in order to kind of implement this project is firstly the data preparation stage and pre-processing stage. Then afterwards is model uh, the model implementation, as well as the finally is the analysis and probably extensions of the particular model. So at the previous meeting, we were up to already the data pre-processing stage, where we have already chosen our data sets and decided on and started to try and code out our model slightly. So this basically progress reports will be what we have done since then. Yeah. So mainly what we have done is in firstly is to finish pre-processing our conversational data set for this topic classification task. Because previously we were looking into the topic classification part, but we haven't fully done the pre-processing for that part. We have only done the pre-processing for the main model of the sequence to sequence generation part. So yeah, so that's the part which we finished. And next, we finished training this bird-based topic classifier, and actually as you can see, right, like this is where the performance that we got from training this classifier wasn't the best. So we had to deeper into and analyze what exactly is the issues, because having a classifier with nearly 62% classification accuracy is not going to allow our non-conversational data to be classified very well. And if the input to is not really good, like basically garbage in, garbage out. So we had to try and see what else we could do with it. So so here's like our main analysis is that there's actually a lot of text with certain ambiguous topics. So like for example, you can see right there, like the health and ordinary life. It seems like it can basically be classified into multiple different topics. So in order to make it less ambiguous, uh, we decided to combine we decided to combine the samples because this keep in mind that this is based on daily dialogue, which is a multi-turn kind of data set. So you have multiple turns, and not each turn's dialogue might not directly be linked to the topic. So what we decided to do is we just decided to concatenate the various turns all together into one single sample, because that will allow us to allow the model to possibly uh, do slightly better. So that's kind of what we did. And another point is that basically for the last the last classification layer, it's not pre-trained as well. So that could be another reason why the performance is not as good. Yeah. So basically, in order to fix this, what we did is to choose very unambiguous topic categories after looking through the data set. And yeah, the ones which we have chosen is politics, attitude and emotion, and health. So yeah, in addition, some of the topics were slightly related. So we eyeballed samples from the topics relationship and attitudes and emotion. We discovered that actually we couldn't really tell the difference between the two. So we decided to just basically combine both of them. Yep. So that is what we did, and we basically retrained the new BERT-based topic classifier based on that. Next. Yep. And after fixing them the updated data sets, we actually are able to train a decent classifier already. So that would be of probably a much greater help in order in helping us to kind of cluster the different samples from the non-conversational data sets in the future. And yep, the next part will be talking about the sequence to sequence model implementation, which you see will go into much greater detail on that. Yep.
Okay, thanks, Xixin. And then I will talk about our implementation of sequence to sequence model. So by now we have already implemented the initialization part of the sequence to sequence model. So basically our method is the model the training the model needs two parts. The first part is the initialization, and that means we train the forward and the backward method together, and then we will use the prediction of the backward model to train the forward model, and then use the prediction of the forward to train the backward model iteratively. Yeah. So by now we have already implemented the first part, that is the initialization of the models. So here is the architecture of our model, and this code is adapted from the GitHub. This project in question generation. So because they use sequence to sequence model and can be easily trained and adjusted, so we use this model architecture to develop our model. So in our model, we have the forward and the backward model has shared the encoder, and they have two different decoders. So during training, we use the forward part use the context as input and try to predict the response. And the backward model use the response as input and try to predict the context. So then during the back propagation, the loss function is defined as the sum of the two sequence to sequence model. Yeah, so by now, actually, our model is still in training, and there is a preliminary results of our model. So we use about this should be I think yes, this should be 30,000 training samples, and it runs 10 minutes per epoch. So by now it has run probably 8 epochs, and the blue scores on the validation dataset it's 10 for forward one and 12 for backward one. So by now the performance of model hasn't been hasn't converged. So I think the performance will improve in the future, I think. So this is the screenshot of our hyperparameter setting. Yeah, so it can be so we adopt the early stop method. So actually the epoch is not that many. I think just 20 epochs, then the model performance will converge. Yeah. Okay, so this is our future plan. So since we only have complement the initialization part of our model, so then we will incorporate the non-conversational data into our model. That means to iteratively train the forward and backward model. So first we will use the backward model to predict some context based on the response from the dialogue dataset, and use this context as input to train the forward decoder of the forward model. And then we will iteratively train the backward decoder like this. So I think the times of iteration is about 5 times, yeah, based on the report of the paper. So after training this, we will do evaluation on the prediction of our model, and to see whether this model works in the English corpus. Yes, so this is our schedule for the future works, I think. These 2 parts is what we have finished by now, and this is our future plan. Yeah, hopefully we can do it in 2 or 3 weeks, I think. Yeah, that's all. Thank you. Any questions?
Okay, do we have questions from the floor? Okay, a couple of different things here. I put in some notes on the Slack, and I think everyone can see them if you want to see. But I will try to do the same for all of the presentations that I'm in. I have more to say about the analysis, but also with respect to the schedule, you guys need to make it clear who's doing what in the following weeks. You know, right now you have it, all 3 of you are working simultaneously on that. You know, one of the things that's needed in the 6101 course is that all members of a team spend time on the project roughly equal to 40 to 60 hours. So unfortunately, that's something that we need to tick off to make sure that NUS is happy that all students have spent sufficient time on it. Okay, yes, the blue scores are definitely between 1 and 0. So these are out of 100 in this case. So we also need to know, just like Wan Hao said, whether the blue scores are good relative to another baseline. Okay, because having a metric score without reference to anything makes it hard to distinguish whether something is good or not. So you can give us some idea about that. And these are for the English data or the Chinese data. Can you say again?
And this is for English data.
the English data.
Yeah,
And
the blue score is tested on the daily dialogue dataset.
okay,
Yeah.
all right. So you have samples of this. Have you guys looked at the actual sample data that you're generating from your system?
We have not yet because the model is still in training. So this
Okay.
is just a preliminary results. Yeah.
Okay, and which epoch is this on? This is partial trained at this point.
Yes, yes.
Uh-huh.
It's
And
about,
how many epochs in are you training at this point?
8 epochs.
8 epochs in. Okay,
Yes.
and you know the blue score is at the beginning, and you know every couple of epochs you should be assessing the blue scores on your dev set. Do you know whether it's improving or not?
It's improving. Yes.
Okay.
The I think the very early result is about 7 or 8.
7
Yes.
or 8.
Yes.
Okay. So it may be plateauing soon because you don't see that much improvement. So you need to get an idea of how the original system works without your innovation of using the backward forward iterative training, right? And to take a look at individual test cases where you believe that the diversity has helped, right? So you need to see, especially when all of our teams go to steps, right, to present their posters, you want to backward engineer 1 or 2 example cases from your data set that show, you know, something that worked really well, okay, like something in attitude or emotion that was enriched because you had, you know, additional data from other places, and some other sample that was worsened by it or didn't help at all, right? Then you need to think about what parameters would help you choose when to use your model and when not to. Okay, maybe uniformly it's good to include, you know, extra information, but usually it's the case that using external data helps for certain parts of the model and doesn't help for others. Okay, so you can try to slice up your data, maybe by certain things. You can do it by topic. You can do it by amount of vocabulary that's complex, or you can do it also by sentence length or something like this, okay? And try to assess blue score for each individual segment, okay? This is what we call the meso-analysis, right? So you're bundling not the whole data set, but a portion of the data set that is specific in some way and trying to analyze whether the performance is the same as in the rest of the cohort or not. Okay, so it may be that it doesn't work, or sorry, it may be that it works really well and really badly for short data, because short data is going to be affected very strongly because there's very few words, right? And that very long data tends not to be perturbed too much by the diversification process. Okay, so you may find things of this sort happening in your data, and it would be good to analyze that. Okay. Also, you can take a look at you know, other forms of analysis or other methods in your experimental setup that would let you change some parameters. So, for example, because you have an iterative framework where you're doing backward and forward training, right? It could be that you can run some iterations with more backward and less forward, or vice versa, right? So in some iterative situations, you would want to, let's say, train one system longer before invoking the other system to do the inverse training. That happens a lot in the reinforcement learning area, like actor and critic systems, where you want to train the actor to be at least somewhat good before the critic has to start critiquing whether the actor is doing correct work. Okay. I'll stop there for a second. So I'll let our other members say something. So if you guys have other input, please go ahead and unmute and ask your questions. It's good to ask because then you'll get a sense of what's required for your projects later on.
I think for the blue score scale, actually, our score is between 0 and 100. We just scale it to 0 and 100. Yes.
Okay, thanks, Yuxi, for answering that question from Guanhao. Okay, I'd like to pause for a minute or two just to make sure that other people have a chance to put up their comments. Hopefully you've had a chance to absorb a little bit of what Yuxi said and Shijun said. Okay, so ladies and gentlemen, let's first thank Shichun and Yuxi for presenting. Okay, so they will be finishing their work very soon. So I think the next iteration sprint, we'll hear from them as a regular update group one last time. But I think most of them will be going on to their next lab rotation. Of course, you guys are welcome to continue to attend if you'd like, or watch the videos afterwards if you think it's useful. Either way is fine. The only requirement is, of course, that your group from the 6101 first part of the lab rotation will have to present the poster in week 13. So I hope you will still manage to give updates to your project every 2 weeks, but it's fine. You're not obligated to because your lab rotation has finished as of today. Okay, so I will try to write some more on your project, Fred, but with that, I think it's time to go to our breakout rooms. So we have 2 breakout rooms, but the problem here is that one of our project teams, Evan Chong's team, is not able to present because I think they're busy. So I've opened the rooms, so I need you to go to the appropriate room. You can assign yourself based on the post. Okay, and then in about 2 to 3 minutes at about 1:30 or so, we'll start the breakout rooms. Okay. So Yuxi and Shichun, you're welcome to split up and go to whichever room you would like. It would be great if you can give some comments to the rest of the students if you can.
Okay, thanks.
Thank you.
Thanks.